One of the beauties of random numbers is that you never know what you're going to get. Every time you run your program, every time you ask for a random number, you get back something that is completely unpredictable. And this is almost always what you want, but very once in a while, it's not what you want. Consider the situation where you've written a program that uses random numbers, and every once in a while, something goes terribly wrong. Maybe an object just disappears off the screen when it shouldn't, or it's much too large, or it's much too purple, or it's not purple enough, but something screwy happens. And you think to yourself, well, if only I could get the same sequence of random numbers back every time, then I could wait until the program hit that moment and catch it. And then I could print things out and I could try to figure out what's going wrong. But if the random numbers are always random, then you never have a chance to do that because you never know what you're going to get. You can solve this problem with the idea of a random seed. What a random seed lets you do is it says to the random number generator inside of processing, I want you to start here. And as long as you say that before you ask for any random numbers, from then on, you will always get back the same sequence of numbers every time you run the program. Let me show you how this works by analogy. Suppose that you wanted to make random numbers by yourself. You didn't have a computer and you just wanted to generate a random number between 0 and 999. So where are you going to find random digits? And you have a great idea. You say, I'm going to get the phone book. The phone book is just full of numbers, and we'll say that they're pretty much arbitrary and random. Now, in a real phone book, the first 3 digits have a lot of similarity because there's only a certain number of exchanges in each area. But let's overlook that for now because it's just an analogy, and we'll say that the digits in the phone book are pretty much random. So here's our strategy. We'll pick a phone book and we'll generate a 3-digit number by pulling out these 3 numbers. First, we'll go to page 3, column 2, line 12. We'll find the phone number there, and then we'll take the 7th digit. Then we'll go to page 8, column 1, line 65, take the phone number there and get the 2nd digit. And then we'll go to page 4, column 1, line 41, and get the 5th digit. That will give us 3 random digits. So great, let's do that. We'll grab a phone book from the stack. We'll go to page 3. We'll look at column 2, line 12, and find digit number 7. And that is a 7. Now we go to page 8, column 1, line 65, and we get digit number 2, and that's a 6. Then we go to page 4, column 1, line 41, we go to digit 5, and we get a 1. Terrific. We have the number 761. So now let's get another random number from 0 to 999. The beauty of this scheme is we can keep the algorithm. We don't have to change anything here. We just grab another phone book. So we grab a phone book and we've grabbed the very same phone book. Well, now if we follow the algorithm again, of course, we're going to get back the same 3 digits because we're looking at the exact same place in the exact same phone book. So this is great if we always want to get back the same values. But if we really wanted random numbers, then we would pick a different phone book. And now, following exactly the same algorithm, we will get a different 3-digit number. So we'll still go to the page, column, and line that the algorithm tells us to go to, and we'll take the digit we're told to get, but in this example, we go to a different phone book, we get a different number. So as long as we use the same book, we get the same numbers. If we choose a different book each time, we'll get different random numbers. Continuing the analogy, when we run a sketch, processing picks a random phone book for us. If we could tell it which phone book to pick, then we'd be certain of getting the same random numbers every time. So how do we tell processing which phone book to pick? Of course, it doesn't really have a phone book. It has another technique where it generates one random number after another using the most recent random number to help it pick the next one. So if we can always start somewhere in particular in this sequence, we'll get the same results every time. So how do we tell processing, here's where I want you to start? We call a routine called random seed. It's all one word and seed is capitalized. It takes an integer and it takes any integer. There's really no rhyme or reason here. Just pick any number. It can be your birthday or your phone number or the street number of your house. any number you want. It can be 3 or 75. Here I've typed in a 5-digit number. I just hit random keys on the keyboard. Now, if I ask for a random number between 1 and 5, and later I ask for one between -15 and 37, and later 0 and width, I will get back the same 3 numbers. And that way I can debug my program. When my program is running and I like what's happening, I'll take out the call to random seed. That tells processing it should pick the phone book at random. When processing picks the random seed for you, it picks a different number every time. It uses something often based on the system clock. So it's a number of thousandths of a second that your computer has been running since it was last turned on. It's essentially unpredictable. So the computer will pick a random seed for you if you don't, and that's why you get back non-repeating values. But if you want to make sure you always get back the same values, call random seed first. This is really a great way to debug your program. When things are working great, make sure to take out your call to random seed so every time you run your program, you'll get a different result. Let's see this in action. Here's a little sketch I wrote that draws 10 random circles. The center, X and Y, and the radius of each circle comes from random numbers. So there are 30 random numbers in all required to make this picture. Now, every time I run the program, processing will pick a different starting random seed, and I get back a different sequence of random numbers. So every picture will look different. And in practical terms, they will never, ever repeat. Now, let's suppose that in one of these runs of the program, let's say this one, something went wrong. And we look at the picture and we say, oh my gosh, there's a terrible error. Something happened. And we want to fix it. We want to zero in on the problem. We can use random seed to make sure we always get back the same random numbers. Let's look at the code and see where random seed would go. Here's my program, and there isn't even a draw. I'm keeping it very simple. We have a setup, we call size and smooth, I call background, and I fill with a yellow color. Now we have a loop, and the loop runs for 10 circles. And inside the loop, I ask for a random number between 0 and width, and I save that as CX, center X. Then I ask for a random number between 0 and height. I save that as center Y. And then I ask for a random number between 0 and I said, well, maybe width over 10. I wanted circles to get big, but no bigger than about 1/10 of the way across the screen. And I save that as the radius. And then I draw the circle, CX, CY, 2 times R, 2 times R. That's the entire program, and I do that 10 times. So each time I run the program, I generate 3 random numbers, I draw a circle. Then I get 3 more random numbers, draw a circle, get 3 more random numbers, draw a circle. Every time I run the program, I will get a different sequence of random numbers. But if I want them to always be the same, before I call random even the first time, I'll say random seed. And I'll just give it some arbitrary number, let's say 3. Now when I run the program, this is the picture that comes out when the random number generator is seeded with the number 3. We can actually notice something really cool. In the upper right, there's a tiny little circle in the middle of a much bigger circle. And then there's another circle sort of to the right of that that's falling off the side of the screen. So that's great. That's our cue that we can easily remember from one run to the next. If I run the program again with that random seed in there, we should get exactly the same result. And there it is. So if something was going wrong, now we're able to dig in and find it because we're always getting the same picture. Once we've solved the problem, we'll take out the call to random seed. I'll just comment it out. And now if I run it again, we get a different picture. And from now on, every time we run it, we get a different picture. Here's the one trick to using random seed to do this debugging. Suppose that you don't have a call to random seed, the way we don't right now. You run your program and there's a problem. And you say, oh man, I've got to capture these random numbers so I can run the program again and get the same result. The problem is you don't know what numbers you were just using because that run of the program has already happened. So typically what I do is I go in and I guess. I say, well, let's try 3. And I run the program and I see if I get the problem I'm looking for. If I don't, I go, all right, well, let's try 4. And I just keep trying random seeds until whatever situation it is that I'm trying to discover, I eventually discover. And usually it doesn't take more than a half a dozen of them. So for example, now I have 5. And notice sort of in the upper left corner, we have those 2 circles overlapping one another. If I run it again, we should get exactly the same thing. And we will every time we run it. And then we say, I've solved my problem. Comment out the code of random seed, run the program again. Different results. So that's random seed. Anytime you want to repeat a sequence of random numbers, somewhere near the top of your program, before you start calling random numbers, call random seed and give it some arbitrary number. And you will always get back the same sequence of random numbers. Once things are fixed, make sure to comment it out or delete it entirely, and then you'll have a program that always gives you unpredictable results with every run.